begin from the 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 starting. So hey guys, good morning, welcome to the channel. Let's learn together. Let me just give you a glimpse of what are we going to do today. Uh, just the video before this. Like we were studying about perceptron, right? When have given I will say a hint in that video that the perceptron algorithm is not the accurate one. I will not say not the accurate one, but it is the first algorithm of in the machine learning subject, I will say. And also in that algorithm graph like this. So yes, the after creating the line or rotating the line, but still some machine learning, 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 machine learning. I will not say advanced topic, but just the topic with right, right, right. So if if you have not watched the previous video of this one, then please go and work from the scratch, and in that and easily you can understand. And also nothing pre-read is required for watching video and video, and it will get a complete idea of what and machine learner engineer will do or a data scientist do in a daily life. I hope you will. And let's start. 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 Let's start then. Okay, and after completing this topic, gradient descent. Tell you that after completing this topic, is nothing but the loop, 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 and loop is nothing but the logic building. So my logic building as well. So hereafter, let's say for 2 to 3 weeks, I will be uploading the basic videos. Basic video will say basic videos means the data analyst videos, such as working on different SQL problem or uh, pandas in the upcoming 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 videos as well. Okay, and then also 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 because machine learning is something which is a 4 month or two. I will say so 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 I will say so. We have different algorithms for different this algorithm 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 is highly important because here linear regression algorithm video or a logistic regression algorithm video or a cluster video. So everything is actually based on your GD. Means I will be quoting this GD inside that, and then we will be proceeding ahead. Okay. Now let's begin, and why, let's understand what is this gradient descent, why it is important. Okay. And what like why do we need this in the machine learning, right? So let's begin, and let me just give you a recap. Okay. So guys, we were having the lines this way, right? And also some dots were this way, right? So if you in perceptron, what were we doing is we were rotating this line, right? The goal for rotating this line was to make all the green dots in one group, all the purple dots in one group. This was the goal. But when we were rotating it, like let's say I have run the loop for around 10 times or 100 times maybe, the accuracy was never 100%, right? It was never 100%. Rather it was around 94, 98, 97, like that it was going. Okay. So and also in perceptron we were rotating this line randomly. Sometimes it was going to the right direction, sometimes to the left direction, sometimes to the center. Anything we were doing, right? It was irrespective, it was irrespective of directions. So this line in perceptron was called the good line, I will say. It was known as the good line. But when we use the GD, right, our goal here is very simple, that we want to create the best line. Now, how do we create the best line? So, before this GD, let's go back to some of the basics. Okay. And in the basics, I will let you first know on what subjects are we going to discuss and what are the important parts from which the GD is going to come. Okay. So in the basics, I will firstly discuss about the first. Uh, okay. If you remember, this was the line and this was a point. Okay. I have discussed this in the perceptron video that we were actually summing of the all the our distance from different points, and we were just summing them up and we were multiplying them with the labels, right? So the code means the formula was W transpose X plus W naught divided by norm of W into yi. Okay, and we were taking for all the points, so I just give it the sum, and this function is known as nothing but your gain function. Okay, gain function. So just you remember this whole thing this way, that gain function is nothing but when we just sum all the distance from the individual point and from between the line. So between the line and the individual point, when we sum all the distance, so this formula is for the distance and we are summing all, so I have used this sum ka symbol, right? I hope this part is clear, and this was the last time we have discussed. Okay. Now in GD, what we do first thing is we don't want the gain. We want to know that, okay, if this is the point and this is the line and this is the point which should be in this group but it is misclassified, then I want to know that how much loss am I going to make. So we here are not just rotating the line, okay, but we also want to understand what is the loss here, right? So I want to first calculate my loss. So G means the gain function of G is equals to minus of L. And what is L? L is nothing but your this formula. So basically this will become this way, minus of sum W transpose X plus W naught divided by norm of W into yi. So this is the formula. Means basically I am just giving a minus symbol here, and that is what is known as the loss function. So the first concept of GD is clear. Now what is GD? That is also one more thing. So what is this gradient descent? Okay. So first moving to with like okay, before moving to the gradient descent, right? Let's understand why do we need this gradient descent. Okay. So let me just erase this part first quickly. So let's understand why do we need our gradient descent. Okay. So just I will give you one of the example. Okay. Let's say okay. When we say W transpose of X, so we know that our weight vector like W1 X plus W2 X2 plus W naught is equals to 0. This is our weight vector, right? Okay, it is not clear. Let me just rewrite this again. We know that our W1 X1 plus W2 X2 plus W naught will be equals to 0. So this is my weight vector, right? This W weight vector, and I am multiplying it with the X vector, and that is how I get this part. Okay. So uh, what is this now? Why do we need this GD and all? So this all concept is known as nothing but your optimization. Optimization. Okay. So optimization, you can just I have written in short. You can just understand. So why do we need the concept of optimization? And in optimization, there are few different concepts, right? One is intuition. Okay. Second is I will just write here. In optimization, we have intuition based. Okay. So let's understand first what is intuition based. So when you see this kind of line, okay, this is a simple line equation, right? Now we know W is weight and X is parameter. I will say X is feature and W is the parameters, right? So basically when you write a line like this, so such as 10x plus 11y plus 3 is equals to 0. So here x is this, y is this, and 3 is this. So what is W2? W2 is your 11, W1 is your 10, right? So let me just give you a simple thing like why do we need optimization? We need optimization because if you take an example, right? Let's say I have one number minus 10, okay? I have another number 10, right? and obviously in between 0 will come somewhere here. Let's imagine a x-axis ka line this way. Let's say this is one x-axis ka line, right? Now let's let's just assume that I will be having around, let's say I am just taking 100 values in middle. Same here also I am taking 100 values. So from minus 10 to 0, I have assumed I am going to take 100 values. From 0 to 10, I am going to take 100 values. So this is my assumption I am just doing. Okay. Now, when I was rotating the line like this, like this, like this, somewhere like this. Okay. So what was happening that each rotation required some amount of time. Okay. So if you just imagine it this way, like any operation in the Python notebook will take around 10 to the power minus 6 seconds. So this much time is required for doing an operations. Okay, any operation. You can say either you are doing plus, multiply, minus, divide, anything you do, it will require this much amount of time, right? Now when you just see this, okay, and you use your I will say permutation and combination, then you find that for this how many combination can be made is 201, because 100 value and 0 is the center value. So 201, okay, to the power of 3 is required. Okay, now if you just multiply this with 10 to the power of minus 6, it will take around 8 seconds, right? It will just take around 8 seconds, and we just take this out and I put this as seconds. This is something called basic calculation. Okay, so what is 3? 3 means to the power of 3 if you want to know also. So let's say I have a data set of 3 columns. Simple, you can just skip this way. So 1, 2, 3. So this 3 is that. And when I do the operation in this, it will just take this much 8 seconds, right? Now, what if I just include one more column over here? So now I have 4 columns. So this will become 4 now. 10 to the power 201 to the power of 4 into 10 to the power minus 6, and here the time limitation will rise up to 27 minute, right? Now if I just do this as 5 columns, so how much do you think the time will grow? It will take around 91 hours. 91 hours. And if I simply just expand one more column, means let's say I have now 6 columns. So with 6 column, this will go up to 2 years for doing the calculation. So basically when you take a line w1x1 plus w2x2 plus w0 equals to 0, and you randomly put the weights like somewhere 1, 2, 4, 2, 3, 5. So anything, any weights you just randomly put to get the best line. Okay, and you have 6 columns, I will say, in a data set, then you will require 2 years to perform your complete calculation, and this code will be running for next 2 years to give you the best line. So you can just imagine how do this issue can affect any company on a, yeah, if I talk about on a company level, then you can just imagine how this issue can impact the company's business drastically. So now how do I optimize this? First point is that, okay, and is this a good method? So you can just imagine how this method is affecting. Okay, now after this there is another method, so which is known as functions. So y equals to f of x. So when I come to y equals to f of, okay, y equals to f of x, when I come to this function, right? So you know this function will give me a line. So let's say my f of x, let's assume that my f of x is x square. So becomes x square. So you can, I have also made a proper this thing graph for you, so easily you can understand. So y equals to x square, you can see, you get a graph this way, right? And the goal of this graph, of this u-shaped graph, is we want to get to the point where slope is 0 or minimum. So we will say when the slope is 0 or minimum, that is the point where my loss is almost 0 or it is less. So that is why we need to calculate the slope. Okay. In machine learning, in mathematics, you have heard about slope. So slope is what? Y2 minus y1 by x2 minus x1, right? Now, if in machine learning, okay, in machine learning, your slope of the same mathematical slope is nothing but is known as derivative. Okay, and when you have collection of derivative, like let's say you have d1, you have d2, and you go to the nth value of derivative and collection of derivative, it is known as gradient descent. So I hope now you are aware of what is gradient descent, right? So let's understand it one by one, right? Okay, how do we calculate the slope? So let's see that part first. Okay, now okay, now you can just see this graph, right? This U-shaped graph. So I'm just going to create that one. Let's just imagine this is that U-shaped graph. Okay, now you can see that the graph is actually touching at a single point. This is that point, right? And I know that whenever the graph is at this position, when it touch the x-axis at this position, this is the minimum point. If you just observe here also, can you tell me if the graph, or if the this u can go beyond your x or beyond your 0? Is it quite possible? No, right? So the minimum point for this function is 0, means 0 comma 0. It cannot go beyond 0 like in some negatives and all, right? So this point is the point where my loss is minimum, and I exactly need to calculate that point only. So I need to get this point, right? Now how do I get that point? One question is that. So when you have a graph like this, okay, a U-shaped graph, means that any graph you have, okay. So in mathematics, what we were doing is we take one point here. Now let's say one line is crossing this. Okay, so obviously this point will have one y value, one x value. Similarly, this point will also have one y value and one x value. So how do we calculate the slope is y2 minus y1 divided by x2 minus x1. Now, when I tell you, like, okay, if you have a graph, if you have a graph this way, right? Now, what are the slope? This part, this part, this part, and this part, right? Now, I am saying that just seeing this figure, this all slope will be zero. This all slopes will be nothing but will be equal to zero. Now, how am I saying that? Okay, just I will give you a simple example which you can remember whole your life as well. So let's say this is your y-axis, this is your x-axis, right? Now I have one line this way, right? This line is what? Let's say this point is 3. Let's say this point is 3. So obviously I have two x ka point here, right? One is 0 and one somewhere here. Let's say 5. So, but do I have one more y value? No, right? So y2 is also 3, y1 is also 3 in this case. So if you just give a chart here, axis here, then can't I say this point, same like this point and this point are those points where y will be 0, and we know anything by 0 is obviously 0. So basically in those points like this point, this point, this point and this point, my y2 minus y1 tends to 0, and thus my slope tends to 0. Right? So I hope this concept of slope, like why do we want the minimum, is also clear with you, right? So in this concept I will also channelize some of the basic things which is highly required, not highly required I will say, but these are some general questions. Okay, so function, okay, y equals to f of x. This function is segmented into two parts: continuous, discontinuous. What is continuous function? Continuous function is a function. I will just give you a single line which you can just keep in mind forever. Continuous function is a function where you can draw the graph without lifting the pen. For example, this graph, this graph, right? So this all are known as continuous function. What is discontinuous function? Discontinuous function is a function where you have to lift the pen. For example, this is a discontinuous graph, right? So I think this part is also pretty clear, like how do you identify which is a continuous and a discontinuous function. Uh, Moving on to the next part, how do we work on a gradient descent? Okay, so for working on a gradient descent, we were now discussing a couple of minutes ago that slope is equals to your derivative. So derivative you all know. How do we calculate the derivative? Yes, it was in 11th and 12th. So let's take a simple example and I will just recall your thing. Y equals to x square. I know y is my f of x. Y is nothing but my f of x. Okay. So how will I calculate this derivative of x square? I know this derivative is 2x, but how do I get that? So there is a general formula for calculating the derivative, and you have to keep this formula with you whenever you are working on an algorithm in machine learning hereafter, because in GD also we are going to use this formula, and anywhere we are going to use this formula, right? So now, being this a single function means a function that just have a single variable, not a single value. So I can just say if x square plus 3x. So I will say this is also a single function. Why? Because x is the single variable. Now what if I just give you 3y, x square plus 3y? So this become double variable. So you cannot use the same formula which we will be discussing right now uh, in this. So here you have to solve using partial derivative method, PD, and that we will also see after couple of minutes. Okay, so let's just come back to this position, y equals to x square. So if I just write this way, f of x, okay, plus a small change in x whole square minus f of x divided by del x. So this is the formula of derivative. Right now, if you just elaborate this, I know what is x here. X is my x square, right? So I'm just replacing the x with x square, and this is a plus b the whole square ka formula. So a plus b means 2 del x minus x square, okay, and one more thing will be plus del x square by del x, right? So when you just elaborate it along with you will be getting, I will not going to solve this now, so you will be getting 2x. So this is the formula of your derivative. So d, and derivative is nothing but it is your slope, and when you have multiple derivative as a array, that is known as your gradient descent. Now let's move to the next part. In the next part, what we will be discussing right now is, let's just imagine, okay, uh, let's just imagine this way that, okay, in I will also give you one more thing. Before moving to the GD also, I will just give you one more thing. You saw there is a graph this way, which is y equals to x square. So how do we work on this gradient descent? So let's say this is a point, okay, this is a point on my graph. Maybe you can just say, let's say 150 is a point, this part. Now what will I do is, 150 is somewhere around, you can just keep it here and you can see. So it is somewhere around, it is around 149.5 and 12.3, right? So what will I do is, I will just take the very negligible value before that point. Means, how do we work on GD is, let's say I took this point. Let's say this is 5, okay? Or let's say this is 25. So I will be taking one more point which is very much near to that point, means this point somewhere, which will be, let's say, around 24.9999, like this. Basically I am just subtracting this 25 with 0.0000 some and 1. So I'm just taking very negligible point. If I just zoom out this part, then this part will look this way. Like say this is that area, this is that area of the slope, and here you have taken one point and you have taken another point here. Now what you will do is you will use your same slope method, the method which you know, y2 minus y1 by x2 minus x1, and you get a value here, right? Now slowly you will take another point here, another point here, and like this nearby point you will be taking, and at the end you will reach a position called as 0, and this position is that position where your loss is the minimum. So I hope this part is clear with you also. So till now, if I just recall you, if I just give you a quick recall, then what we have discussed is, we have discussed that slope in our mathematics, which is this slope in our mathematics, is known as derivative in machine learning, is known as gradient in the algorithm, and the collection is known as gradient descent. How do we work on gradient descent is exactly this method which we follow. So I hope this part are quite clear with you. Everyone is quite clear with your part. Now, uh, let's just say you have, okay, there is another concept which is known as chain rule. There is this concept called chain rule. So why this chain rule is important? Because you will never, you won't be having a point always, or all or line like this. Okay, so you can have somewhere this also, like plus 3y plus 3. So you can just see how the line is changing. Now if I just give it as 30, you can see how the line is changing, right? Let's say keep it as 10x square. Let's say 10x. I don't know where the line has gone somewhere. So the meanwhile means, what I wanted to show you is, you have all noticed that how the line keeps on changing, like means how this line changes, you have seen that, right? So if I just put it x and just see, 1 second. So this is the line of y equals to x plus 5y plus 10. So now imagine this is a line, okay? So how do you work on that? Means basically I'm saying that a function with a function is what is solved through chain rule. So I have f of x, means what is this? I have f of x, okay? What is my x? It is g of x. So the complete thing, if I just merge them, I get this thing, f of g of x, a function f with another function g and with the element x. You can just keep this thing in the mind. So how do we solve this? For solving this, we simply use a chain rule method. Okay, so using the chain rule method, I will directly give you an example. Let's say I have e raised to the power minus 5x squared. So you can see I have function within a function, means my general function was like this, e of x. Now my x is minus 5 to the 5x to the power of 2, means 5x square minus 5x square. So one function, another is second function. So a function within a function. So how do we solve this? For solving this, we take the first value as it is, means e of minus 5x square. We will just take f of x first, then we multiply it with the derivative of this part. Means we have derived the first part. So e of x ka derivation is e of x, right? So this is our e of x, e raised to the power minus 5x square. Now I will be deriving the x part also anotherly. So minus 5x square ka derivation will be 10x, means minus 10x. So if I just give it a single go, I will be saying that minus 10 e to the power, or ex I will say, simple. And this should be e to the power 5x square, means minus 5x square. So I hope the chain rule concept is also clear. Okay, I don't know if till now I haven't come across a situation where I will be explicitly using the chain rule method to derive something in the algorithm. Okay, but generally it is said that these are the pre-reads for the algorithm. We in today's code also we are not going to use this anyways, right? But this is the pre-read, I will say. We need this pre-read, right? So let me just recall you this part, not this chain rule, but till now what we have studied. We know what is slope. Okay, from the slope, when we do a single derivation of a function, and single derivation is denoted as f dash x. So this is known as derivative, and derivative is nothing but known as your slope. So till now we have studied this much part. Now if we if we just move ahead with this function, and a couple of minutes ago we were discussing about partial derivation. So in that case you will have obviously two variable in f of x. So f of x comma f of y. Now you can see you have two variable, something this way, x and y together. So how do you derive this? And yes, this is something which we will require in the code. So to derive this, what I will do is, okay, let me first explain that how do we solve this kind of problem? What is the general method of solving this kind of problem? Let's understand that as well. So to solve this kind of problem, right, what we do is we generally derive the x part first, then the y part next. So how the function will look here? F, okay, means f is function of x plus delta x, okay, one second, comma y minus f of y plus delta y comma x the whole divided by your delta. So if you have seen this method, this formula, then easily you can also remember or recall your method when we were playing with the single variable. So that was function was f of x plus del x minus f of x divided by del. So if you just observe it very carefully, then you can see that I have done nothing, but I have just taken this part first, f of x plus del x, this part, comma y. Then I have derived with the using y also, and I have taken y plus del y, comma x. So it is quite simple, right? And why? And this type of function is also known as the partial function is also known as the partial derivative method. So yes, if there are the cases where you have this kind of scenario, the line is this way, then you need to use the partial derivation also, right? So I hope this formula is pretty clear. If also you have any doubt in the formula, you can just do it a simple Google and you will easily find the formula with you, because the formula is going to be constant throughout. Now, after we know what is partial derivation, what is slope, everything we know, right? Now, here comes a important point of, uh, I will say, maxima and minima. Okay, so what is this maxima and minima? Let me just give you simple slope. Say, consider this is a graph, right? Consider this is a graph. So everyone agree with me. This point and this point will be your maximum, right? Max, and those tangent with the black would be your min. How this is max? This is min. Consider this is a graph. So the above y would be definitely higher than the below y, right? So y1, y2. So you can obviously say that y2 is greater than y1, right? So how do we, okay, now you have understood what is maxima and minima, right? In a simple terms, I have just explained you. Okay, now imagine one point that how do you generalize this formula in the algorithm? So here comes another step of derivation, which is known as double derivation. Means f double dash of x. Just take this simple formula, simple line x square. Okay. Now when you do single derivation, you get 2x. When you will do double derivation, you will get 2, because x will cut off, right? So x just get cut off. So you just get 2, right? So what I did here, I just did d by dx of x square, which is 2x, and we know that derivative of x with respect to dx is always 1. So when I do the double derivation, it tends to 2. Now let me just quote that graph again, x square. right? So you have this graph, so called y equals to x square, right? So can you just tell me is what is the maximum point this graph can go? Or let's say if I just write 2x square. Okay, one second. Okay, so now let just can you just tell me what is the maximum point this graph can go? It is pretty clear, right? The graph can go towards the infinity. Like how many times we quote the x value, we get another y value, isn't it? If now let's say at this point x is 0, then at this point somewhere x is, you can see the value of x, 11630. At this point 2300, this point 2920. So n times we can give the value of x, and thus the graph also goes towards the infinity. So everyone agree with me, right? This graph, the maximum value this graph can go is infinity. So what is the minimum point then? Exactly, the minimum point is 0, because beyond this the graph, if also it won't, it cannot go, it cannot move. So this is the minimum point of a this x square ka graph. So the same thing, how do we calculate generally? Now let's say you know how the line looks, you got this. But if I just give you a tough function, like let's say x to the power 4 plus 3y plus 10 equals to 0. Now I want the maximum and the minimum point, min. How will you get this done? So to solve this, we want this function f double dash of x, means the double derivative function. So now I think you can also link why we have used your this thing partial derivation, why we have looked the partial derivation का formula, what is why we need the chain rule, why do we need the derivation. So I think now you can just uh, link those part in this single question. When I just gave you a function 3x ka power 4 plus 3xy ka square plus 10 is equals to 0, and I told you that when you do the double derivation, okay, you will get the mean and max value. Now if you just see this function very carefully, you can easily understand why we have done this part. Partial derivation, when you see this function 3x 3xy square, or just simply I will just say it as 3xy, right? So when you say this function, can you recall that this is a part of partial derivation, isn't it? This is a part of partial derivation because we have x and y. Also when you see this part again carefully, can you recall we also have a chain rule over here? Why? Because 3 into x into y. So firstly you will derive with x, then you will derive with y. Let me just give it the black so you can understand. Then you will derive with y. So that is why we have understood the basics of PD, chain rule and the derivation. And hence this portion is actually being used. in your equations. So I think now the concept of why we have used or we were looking the basics is pretty clear with all of us, right? So now let me just quickly take this all out, everything. Now you can just focus on how do we calculate the gradient descent. So I will say my function is y equals to x square. Simple. Now, okay, before moving to this, how do we calculate? Let me just give you the goal also. Why? Okay, let's understand what. So I hope everyone is clear with what is gradient descent. What is this term gradient descent? We studied in a like from last 1 hour we were studying about this. Slope in mathematics is derivative in learning, machine learning, and when you just give a collection of derivative together, it becomes the gradient descent. So what part is clear? Then we also came to know why do we need gradient descent. We want this gradient descent because we want to calculate the loss, and gradient descent will give us the slope exactly at that point where the loss is minimum. If you also forgot this, then just focus on this graph. The loss is minimum, loss is zero, right? So we also know why do we need gradient descent. And also you remember that whenever we if there is a line and we want to give some random values to rotate this line, it may take us years to get the best line. So that process was not optimized process, it is not optimal. So we are taking gradient descent as the first portion of the optimization to rotate the line in with a good accuracy and to get the best line out of that, right? So why part is also clear. Now the final part, how how do we calculate the gradient descent? So to calculate the gradient descent, everyone can just focus here. I told that gradient descent can be calculated using a formula. So what is that formula? F double dash of x, one part, right? So to calculate a gradient descent also, uh, I will give you some steps. Okay. So first step is you can also note this along with you. So the step one is you have a function. So just write that function, right? After that, start with a random value. Just give some random value here. Like this graph was this way, right? So we have taken 5, 25, 15, 10. Some random value you can just give here. Just the random value should start at a point. So I for my the first random value was 25. If you remember that formula, like when we were calculating the slope couple of minutes ago. So my first random value was 25, right? Then I choose a direction. I choose a direction. Okay. Uh, you know that, right? When I take a graph like this, I took a point. Okay. Now my vector from this point, you know, vectors, what is the concept of vector, right? Vector will always head toward upward direction, right? Now, if I after solving the gradient and I get one value, if I move upward, then am I going to go towards the lowest point or I am going away from this lower point if I move in the direction of vector? It is quite obvious, right? I am going away from this point, but rather I need to come back to the minimum point. So what changes are we going to make in the function? That is another point. Now, once you got the first point, Then you take another random point which is very close to that point, and then you code the function, right? So now let's work on how the quotient will work. So the first step one is clear, and this process also you have understood. Now comes the derivation part. So derivation of x square is 2x, right? So once you get this 2x, you can just say that this 2x is nothing but your gradient, right? After this, what will you do? After this, you go to the next formula. So what is the formula of getting the new value of x? Means, see, I took one value 25, my next value was 24.9999, some point was there. Okay, after calculating the slope from here, what should be my next? I should take some other value also, right? Then I should take some other value also. Then I should take some other value, and finally, I will get into the zero. No. So how am I supposed to take this value? Should I take it randomly, or is there a code for that, or a process for that? So that process is known as x new, right? So you can just give it this way: x new is equals to old x minus learning rate of your gradient. So this is the formula which you are supposed to use to get the gradient, and the number of times you are getting the gradient is known as your, and storing it at a place is known as your gradient descent. So now just let's take this same formula with the example of x equals to y equals to x square. When I write y is equals to x square, so the first derivation will give me 2x. Now just take a random value. Let's say we have taken 13 over here, like x is 13. So what is my first x? X old is 13 minus learning rate. Okay, I will explain what is this learning rate in a couple of minutes from now. Into 2 of x. So 2 of x is what? 2 of x is your gradient. So into gradient. So into 13. Learning rate into 2 of f of x. Right? So what will you get here? 13 minus learning rate of 26. I hope this part is clear till now. I have just taken a random value of x as we were discussing. I have quoted here, and this becomes my x new, means my new x, right? So what is this learning rate? So this learning rate LR is also known as your step value. Means when you have taken one point and you are supposed to take another point which is very near, so what is the gap between this point? That is your learning rate. So in our case it was around 0.00000001. But to solve this it in an easy manner, I am just going to take this learning rate as 0.01, or let's say I am just taking it as 0.1. So approximately when I solve this thing, I get around 10.4. If I just rewrite the whole thing again, so 13 minus 0.1 into 26. So 0.1 into 26 is around 2.6. 13 minus 2.6 is around 10.4. If you just do a calculation, then if it is also wrong, then put the actual value, right? So now when you get this 10.4, this 10.4 becomes your new x. Now again the formula of gradient descent start from that end again. So now you will have 10.4 minus 0.1 into 26. Not 26. I am sorry. Not 26. Rather it will be 2 into 10.4 because now my x value is 10.4. And when I solve this, I get another value, and that value will become my x new. And then again the same thing will happen. Then I get one more value. Then again same thing will happen. Then I get one more value, and it just keeps on going. At the end, you will reach to the position where your slope is 0. So I hope now if I just if I just recall you with a simple diagram of this part. So we started at 13. Let's say this is 13. Then we got a new value as 10.4. Then another value we get, then another value we get, then another value, then another value, and finally we reach to the position 0. So from 13 to this position, when we were going, we have taken a random value was this, and then we have taken a small portion, which was 0.001. Okay, in our case it was 0.1, I think, right? So 0.1. So if you just minus it with 0.1, so 13 minus 0.1, which will be around 12.9, right? So my value was 12.9 at this position. So same thing, once I just assume one value, the second, then I am just assuming a step size, a learning rate, then I put it in the formula, I get a new value. And once I get this new value, I can simply run my loop. And this loop will go till this value when the slope becomes 0. So I hope gradient descent in mathematical terms is pretty clear with you. And you have also understood complete scenario of what is gradient descent. So gradient descent, now let's take a quick revision. Okay, so what we have studied till now, or what we have discussed till now, is we know when the line is this way, and here are some points, and where we want to rotate this line, it may take us years to randomly guess and code the thing. So this intuition process is actually wrong. I will not say wrong, but it will take a lot of time. So we have directly reached to the function types, the gradient descent types. So in gradient descent, we saw what is f of x. We denoted f of x is equals to your y. We also saw how to solve this f of x, the derivation part, in three different ways. One is simple derivation method, one is partial derivation method, one is your chain rule. So why do we derive that? Why the derivation is actually needed? Because to identify the slope where slope is equals to 0, we need derivation. Now, What is double derivation? So double derivation is nothing but it is a way to find your minimum value and your maximum value. Great. So I hope this part are pretty clear with you. Okay. I thought we could have also finished with the coding as well, but that the issue is the video will go extreme long, and I don't want to extend the video unnecessarily. So let's do it this way then. What we can do is, mm, let's do it this way. We will make we will give this whole thing as a part. So this is gradient descent 1. It will be uploaded as gradient descent 1. The next coding part will be just of half an hour to 1 hour. It will be as gradient descent part 2. So it will be also with you like what is the numerical part of this and what is the coding part of that. So when you combine them together, it will be completely in your head forever. Okay. So before closing this video, let me just give you some of the things also. These are fixed things. So when your double derivative is greater than 0, that point is minimum. Okay. When it is less than 0, that point is maximum. When it is equals to 0, that point is known as saddle point. So these are key things that you should keep in the mind. Uh, Generally, the saddle point is not used in most of the part, but this part is quite pretty good if you just understand this. And also, you can just recheck this part because this is quite confusing as well. The minima and maxima part quite confusing in this sense. I am saying, like if it is greater than 0, it is maximum or minimum. Just once also you just recheck this. I'm also requesting you to please recheck that as well. And and what else, guys? Also, you can just before ending, I just give you another function also. Let's say x square plus y square. Okay. Now you know after doing okay, you have understood partial derivation. First, we will solve the x, then y. After solving everything, what will I get? I will get 2x and 2y. Right? Now, if I just randomly put the value of x and y, let's say my x is 2, y is 1. Right? So what am I going to get here? 2 into 2 4, 2 into 1 2. Okay. So what is this? This is known as gradient descent, collection of derivatives. Simple. Now I think that word, that terminology, collection of derivatives, is also clear with you. uh, okay, then let's end up this video. Have a great day. Please visit this video. If you also have any doubt uh, in this concept, please let me know. I will be super excited to help you with this. In the second half, I will be recording the next video also. That video you will find on Wednesday. This video you will find today, if possible. And if I record the coding part also, then you can find the coding part tomorrow also, not an issue. But this video will be uploaded in the YouTube today. Please do visit the channel. If you also have any doubts in this, I will be super excited to solve your doubts also. Please let me know. If you also want to discuss, or if also you want to change any part of this program, like what we have discussed, you can again let me know in my LinkedIn as well, right? So I hope you have enjoyed a lot. You have understood a lot of concept today, trust me. And this concept are the pillars of your machine learning. And the next video when I will be putting the code of the same things, of all the same things, right? And then everything will be super duper clear with you also. So my first code will be based on x square. Okay, we will see the same thing like the gradient descent thing, like first point, second point, this part. Then I will also show another code where I will be giving you a 3D visualization of how this vector is moving towards the upward direction. You, as we are discussing this learning rate, like minus of learning rate, then we were doing the G, right? So why this is minus? Why this is not plus? So this concept will also be clear when I just do the code. Great. So I wish you all the best. Please visit this, do a deep end study on this. You will be really happy when you get this concept super duper clear with you, right? So have a great day. Bye guys. Please do like, share, subscribe. All this is all your channel only. So anything you want to do, you can do. You can comment anything up to you. Have a great day, guys. Bye bye.